Hey, this is Tom from Audio Ordeal, and I am going to be following up on the kick drum tutorial for Reaktor. So last time we built a kick drum in Reaktor, today we are going to build the next step. This is a snare drum. Now if you haven't seen the first video, I do recommend you watch it because we will race through the first bit. I will start from scratch on this one but not explain as in depth on what I'm doing for starters. This is just so you can follow along. But this module is the basis for many modules and many different drum sounds, so it's always wise to start from scratch. If you haven't already, I'd really love if you guys could give my channel a subscribe, give my videos a like, and it was per request that I continue this series because people have found it to be useful. So I hope this video is useful. If you have enjoyed it, please leave comments. Okay, to the tutorial. So the first thing we need to do for this one is we need to insert the control, the trigger. This is the gate. When you push a key down on your keyboard, it sends a gate signal. We don't need to worry about note pitch just now, just a gate signal. So what is a snare drum? Well, a snare is obviously a drum with a skin over the top, and on the bottom it has a second skin with springs stretched across it. These are called the snares. When the drums hit on the top, the snares on the bottom vibrate and smack against the bottom, and that causes a very crisp snap sound. So we want to mimic this when we are making our snare drum. So the snap sound can be compared to noise, and the resonant drum hit can be compared to maybe a sine wave. Shall we start off with sine? Let's do that. So this is the two modules we have. In various analog and digital drum machines, some only use noise, some use both, and the more complex ones use both. Reaktor is a very easy environment to build stuff in, so we are going to use both. Now then, what we can do, just to start off, make sure everything is working, we'll just hook them up, and we'll need to use an add module to combine them. Add, and send to the outputs. Now I'm going to create a pitch, let's just constant for now. Make sure everything is working. Okay, so now we know that the sound is working, we can move this over, and the first thing we want to do is we want to play about with the sound and decide what sound we want. So what resonance, what size snare we are using. So to do this, we open up the panel just by clicking on the horizontal split, making sure it's on panel mode, and we're going to change that constant to a control. So then I like to always, when I'm setting constants, create a control first so I can play through and see what I like, and then read the value and set that as a constant. So we're going to use 54 as the value. 54 seems to be a good number. It's pretty quickly, I just chose that. It's roughly where I want this snare sound to be, and don't know exactly why, but let's keep it that way. So 54. Now we know that's the pitch we want. Create constant, and let's just change it to 54. Whatever value you decide you like for your snare drum, you can put in. If you'd rather have a changeable pitch, you can keep your pitch knob in. It doesn't really matter. Sometimes it's just nice to have a very tidy, clean interface. So then, we have this sound. It's not exactly a snare drum, is it? So the first thing we can do is create an envelope. Let's go through. We have a big selection here. AD, AR, ADR, ADSR, whatever. Now, what we need to remember, our standard synth will use ADSR. The attack, and then it decays to however long you're holding the key, and then it releases after you're holding the key. With a drum hit, it's not like you're sustaining the note, you're not holding the key down, it's just you hit it and it's more or less the same length each time. So we only really need an AD. So this is what we have. Trigger, we can set the trigger to the gate. A, well let's read what this says. Control input for the output amplitude, typical range 0 to 1. Let's create a constant, let's do 1. Or in fact, what we can do, built-in module, let's make it a bit more advanced, and we'll do the velocity. So the velocity sends the value, and that can change. Let's just go into the velocity properties, make sure maximum 1, minimum 0. Perfect. Now the output can go here and the output can go here. Now we have our controls, create control, create control. We have our attack and our delay. Let's play about with this for now and see what we like. Now, understanding that a drum hit is very fast attack means we can quickly stray pretty much to 0, and understanding that drum have very quick decays, we can bring it down quite a bit if need be. So, bonus segment, I have just created a hi-hat. But this video isn't about hi-hats. I may as well just upload this video again when I am doing hi-hats, but we're looking for a snare. So there we go. If that's all you want, you can end this video now. But we're not just going to give up that easily. We want a very advanced sound. Now then, to make this more advanced, we need to realise that the drum resonance here and the snares on the bottom operate differently. When the drum hits, it resonates pretty much immediately, and the snares kick in almost immediately after that. The snares are very crack sound, so they come in fast, they end fast. The resonance happens for quite a while longer. The drum might ring out a bit. Drummers use something called moon gel, which just stops the ring of the drum. Depends what we want. So we could have a long ringing, long resonance drum, fast crack, or we could have them the same. Let's make it a bit more controllable. So let's just do a standard duplicate. There we go. And we'll call this AD noise and AD, and we'll call this resonance. Switch this over. There we go. And all we need to do, bring these over and lock it again. Now we have a completely controllable sound. So as I was saying, the noise, which is going to be these ones, if I click on this, it highlights decay. Click on this, highlights attack. Really great tip for if you've got various knobs all named the same. If you don't know which one it corresponds to, click on it and it lights up. So we've got it all in the right place. We know that the noise is fast starting and fast ending, so we can bring this down and we can work the sound up. Let's do that. Now then, let's play about with the decay of the actual resonance. So if you've ever heard a snare drum that just needs a bit of padding down, it'll sound like this. It's got a really big ring to it, it's fairly horrendous. Now then, this is where the ring really stands out. We realise it's not quite as accurate as we want. So let's use a bit of a noisier oscillator. Let's just stick with something quite simple, and we'll use a triangle wave. So same pitch, just delete the sine wave, same amplitude, and we'll just send it here. Now then, let's have a listen. That's a bit nicer. So what we'll do, we'll just turn this down a little bit. There we go, that's a bit better. What we could even do is blend the triangle and the sine one. So let's do that. And let's actually do a sine one instead of duplicating the triangle. Send pitch to that. Let's see how this works. Now when we're adding more than two things to the add module, hold control, click and drag, and it adds one. So that's a little bit nicer. I wonder what happens if we send the sine oscillator to the frequency and remove this. Not much happens, so let's just leave it. Let's control, drag, and we'll just delete this background wire. because we don't want that. So we have this. We could even duplicate this again, and we'll call this resonance T for triangle and resonance S for sine. And we'll just do that and unlock here. So attack, decay matches here. Now the sine can go on a lot longer than the triangle, so let's shorten the triangle and lengthen the sine. In fact, what we can even do is change the pitch of the triangle and the sine. So let's make the sine a whole octave lower. So 54 minus 12 is 42. Let's give this a shot. So let's create constant and let's do 42. This might not work, but who knows. Okay, that's way too deep. So let's add 7, we'll go in fifths. So 42 add 7 is 49. Ooh, now that's sounding quite good. Let's do 54 add 7, so 61. Remembering that 49 sounded good. That's way too much. So let's go back to 49. And we quite like the ring, so let's switch that around. 49 and 54. Let's see if this works out. Brilliant, so that's really good. We don't want the ring to be as loud as it is though, so this is really simple. We'll just built-in module math, multiply that to that, and let's create constant. Let's just make it 2/3, so 0.66. Brilliant, so what we can do, we can duplicate this multiply, because I quite like this. Copy, paste. This might be very handy for the triangle section as well. And we can even make this smaller, 0.4, let's try that. Brilliant. So see, already we have all these little tweaks that we can now play about with. So, I don't like having all these controls because it's a clunky interface. So let's look at the value for each attack. Let's just say every attack equals 0. So built-in module, math, constant, 1 will do for this because it's more or less the same. Let's just replace every attack with 1. And I am aware that I just deleted all the attacks, create constant 1. Make sure all the constants are somewhere where we can see. Now the decay is 26, 26 and 38. So let's do this again. Decay, create constant 26. Just get it neat and tidy. 26. And this one, create constant. We decided 38. Perfect. Remove that. Oh, I've just deleted the attack. Now we can move these up, get it a bit tidier. And if you watch my videos on Reaktor a lot, you'll notice that I try and tidy up as much as possible. Not because I like to be tidy, but because I make mistakes. And mistakes are easiest to fix when you know what's gone wrong. So there we go. This is a very easy to follow schematic, and we have a snare drum. But again, we want to go further, so let's move this across, and let's built-in module, let's play about with some filtering. So let's do a Pro 52. Let's play about with this. Who knows where this is gonna go? It could sound great, it could sound awful. This is the magic of sound design. So, pitch, create control. So now we have one control again. It's all it comes down to. Let's add a resonance control, and this just allows us to play a bit more. Snares are quite resonant, so maybe we'll want this. Let's play about. Again, we've got our hi-hat sound. This is really simple drum synthesis. You know, it can be made as complex or as easy as you like, but it all boils down to quick sounds are all the same. So I don't usually like this filter for this particular application. Normally I do. Let's just always reference against what it was before. Right, so let's try a different filter. Let's try something. Let's try the ladder filter. I'll do a much less steep curve, just the low pass 2. In, create control, just pitch and resonance again. So that adds quite a nice hit. Maybe we'll use that. So all we need to do, remember keeping it tidy all the time, is let's do an add module, or even better, signal path. Let's add a crossfade. So we have this coming from 1, and then the dry signal coming from 2. And all we need to do now is create control, crossfade. I don't like the faders, so let's just do a knob. And now we can blend between the filter sound, the pure hit, and the tone. So let's have a little listen. That's pretty good. So once we figure out what we want the hit to sound like perfectly, if we do it a bit higher, because it's resonant, it won't have as much of that resonance in it. The actual skin resonance, which we're trying to mimic, but we don't want it to be too much, hence turning it down. That's pretty perfect. Amazing. So this was the final part of making a snare drum. We can go much deeper, especially if you tweak it yourself and find out what you like, but we have a pretty decent setup. The only thing we really need to do now is 94.66. So let's just replace this with create constant, and we'll make it 94. And the great thing is 0.66 here, we can just save time and send that. And that's a great thing about constants. They're constant. No matter what they send to, it's the same value. So it just keeps everything tidy, unless you don't want a mess of wires, but sometimes having only 1 or 2 units like this is really handy. We can bring it up if we want, just here, and there we have it. So if you think you could have done this differently, if you liked what you've seen, please give a comment, and make sure to like the video, and do subscribe to the channel because I will be covering more of this. Thank you so much.